Welcome to the next installment of Further Mechanics. Right, you can check out the title down here. Now, today we're going to visit one of the further mechanics topic, which is called linear motion under variable forces. Right, you can see the description down there. If you like what you are looking at, don't forget to click the subscription button so that you can receive updated feed of videos. Right now, under this topic, before we start up, we have to get used to some of the terminology. Right now, let's take for instance, we have an object. Okay, hold on. Just let me clean this up. It's not so straight here. Okay. Now let's assume that there's an object P, a particle P, start to perform linear motions starting from position O. And then the displacement from O is labeled as x, whereas the velocity of particle P at time t is given as v, meter per second here. Right. Now, what are the relationship between displacement, velocity, and acceleration? Okay, here it is. So velocity is defined as rate of change in displacement. In terms of calculus is dx dt. Whereas acceleration, we are talking about linear acceleration here. So acceleration is given as a rate of change in velocity, dv dt. Now, indirectly, this is also the second derivative of displacement. And then, by using chain rule, we can obtain another version of acceleration. In this case, acceleration is also given as dv dx by dx dt. Now we know that from equation number 1, dx dt represents velocity. Therefore, we can rewrite acceleration as v dv dx. Right, now these are all the fundamental and basic connections between calculus and mechanics. All right, since we are ready, let's get started. All right. Question number 1. A particle P of mass 0.5 kg is projected vertically upwards from a point on horizontal surface. A resisting force of magnitude 0.02 v square Newton x on P, where v meter per second is the upward velocity. Now that actually gives us the direction of where P is moving, and then its height of x meter above the surface. The initial speed of P is at meter per second. Now, before we try to apply calculus to solve this problem, we have to illustrate that mechanics behind this problem. So let's do some drawing here. So this is the ground here. Okay, let's do the ground. So this is the ground. The object is being projected off the ground with the initial velocity of 8 meter per second. Okay, and then while it is in mid-air, so I try to draw another diagram here. While it is in mid-air, don't forget the directions of velocity is upward. While it is in mid-air, there is a weight acting on the object. In this case is 0.5 g. Just to clarify, g is 10 Newton per kg, gravitational field strength in this case. Now at the same time as the object moves vertically upward, there is a resistive force of 0.02 V square acting on the object, right? And then those are all the forces that is acting on the object at this point of time. All right, so let's look at now we fully understood the mechanics behind this problem. Now we are ready to solve question number 1. Let's look at question 1. Show that while P is moving upwards, V is satisfied by this differential equation. Okay, now to do that, we have to revisit Newton's second law. Newton's second law states that the resultant force is directly proportional to its acceleration, linear acceleration. Now, based on this diagram here, we know that the resultant force in this case is 0 minus 0.5 g and then minus 0.02 v squared, right? Because there is no upward force, so we represent 0 as the upward force. And then there are 2 downward forces here, so we have to subtract off those. And then the resultant force here would yield the acceleration, or would produce accelerations on the object itself. The mass is 0.5, so I'm going to write that down. Now we can write as dv dt in this case, or we can write as 0.5 v dv dx based on this relationship here. Right, now just let me rewrite this. So we have dv dx is equal to negative 0.5 g v squared. Now doing some simplification, we will be able to obtain this. Right. Now that will be negative g. Now since g is 10 Newton per kg, so we'll write this down as negative 10, and then if you divide this, you would get 0.04 v squared. Therefore, we have successfully shown this differential equation for number 1. Okay. Now number 2, find the greatest height of P above the surface, greatest height of V above the surface. Now to do that, we need to solve this differential equation. Right? Now I'm going to do that here. We're going to solve this differential equation. To do that, involve some integration. Right? Now before that, I'm going to rewrite this as in order to reverse the process of derivative, we have to perform grouping first. Yeah, we have to group those terms, like terms together. So in this case, we have v over negative 10 v squared dv. And then that would only give us a dx in this case. Now, once we've done with the grouping, yes, then we can perform the integration. Reverse process the derivative. Okay. Right, now there are many ways to actually integrate this. Now, the easiest way is to integrate the right hand side expression, which would actually give us x plus c. Right, so we are done. But the challenging part is your left hand side expression. Right, now, one way to do this is we can integrate this using a substitutions method. So take for instance, from here, I can let y, okay, let's do y then. Let y equal to negative 10 minus 0.04 v squared. Now we know that dy dv is negative 0.08 v, and then therefore in this case we can actually write that down as v dv is equal to negative 1 over 0.08 dy. Okay, and then that is basically the same as okay, just let me calculate that for a while. Is 12.5, so negative 12.5 dy. Right, so just let me check one more time. Yeah, so it's negative 12.5 dy. This is what we have at this point, right? In the meantime, you can organize your thought on how to exercise substitution method to perform antiderivative or integration in this case. All right. So if you are ready, I'm going to erase off this so that we can work with this integration. Okay, so just let me erase this. Okay. Just let me rewrite the integrations that we have previously. So we have integrations of v dv over negative 10 minus 0.04 v squared equal to x plus c. That's what we have previously. Right, we're going to continue from here. By using substitutions, we can rewrite the numerator. As you can see, the numerator is given as v dv. So we can replace the numerator as negative 1 over 0.08 dy in this case, over the denominator has been substituted with y, so we can write that as y. Integration is still there, equal to x plus c. Right. So from here is basically since I have converted 1 over 0.08 to negative 12.5, so I might as well write as 12.5 here, 1 over y dy x plus c. Now we know that the integrations of reciprocal of y yield ln. Now therefore I can rewrite that as negative 5 ln y equal to x plus c. But y was introduced by myself. Y is represented as negative 10 minus 0.04 v squared. So I should replace that with negative 10 minus 0.04 v squared. Right, now in this case, because we are dealing with ln, so I better put a modulus sign there for the x plus c. Right. So I hope that is clear at this point. Okay, right. Again, next we're going to find out the c at x equal to 0. That is when it's on the ground, when x equal to 0 meter, the initial velocity was 8. So when this is 0, initial velocity is 8 here. So let me try to complete this. We found that c will be equal to negative 12.5 ln. Now v is 8 here, 64, that will be like, let me see, 256, okay, 256, 2.56 then, so 12.56 modulus. Okay, so after modulus is 12.56. Now that is my c. Now once I've done this, yes, I can write down the expressions for y. Okay, so just let me erase this. Very limited space to write here. Okay, maybe it's time for me to erase this then. Okay. So from here, I can rewrite my equation as negative 12.5 ln. Since this is modulus, so I might as well just change it to 10 plus 0.04 v squared equal to x. C is minus 12.5 ln 12.56. And then as usual, I can join the ln together. So if I join the ln together, I'm going to have 12.5 ln 12.56 subtract off with 12.56 ln 10 plus 0.04 v squared equal to x here, and then therefore I can combine this maybe. Let me see, 12.5, oh sorry, this one is 12.5, I think I wrote it down wrongly. Just let me correct that. That's 12.5. Okay, now we are good. So we can write that down as 12.5 ln 12.56 over 10 plus 0.04 v squared equal to x. And then of course you can restructure these algebraic equations as, okay, you can restructure it as 12.5 10 plus 0.04 v squared equal to x over 12.5 here, and then therefore we can actually write as let me take a bit of shortcut. So in this case we have 12.5 e negative x over 2.5 then. Okay, I hope that is clear at this point. Okay, so just let me clean up this section here. Okay, so let us see what we have. So from here we have 0.04 v squared is equal to 12.5 e to the power negative x 2.5 here minus a 10, and then v squared is equal to we have let me see, 150, so that is 12.5 over 0.04 e negative x over 2.5, and then subtract off with 250. Okay, and then you can simplify this. For instance, okay, so just let me calculate that manually. So that is 3 3 1, okay, 3 1 2 3 1 2, let's see, 8 25, so 312.5 e negative x over 2.5 minus 250. Right, now that is the v. To answer number 2, we need to find the greatest height of P above the surface. At the greatest height, okay, at the greatest height, we have V equal to 0. Right, now that's the concepts of mechanics. At the greatest height, the velocity no longer increases, so V must be equal to 0, and then therefore 312.5 exponential negative x over 2.5 should be the same as 250. So by solving this, we will be able to obtain, just let me see what we have here. Yep, so just let me solve it very quickly here. Let me get my GeoGebra. Okay, that will be okay. Let me do it very quickly. Okay, all right, that will be let's see, so ln 250 over 312.5. Yep, and then that would be 2.5. So negative 5.6. So we have negative 5.6 here. Therefore, we can conclude that this is negative 5.6 meters. So the greatest height of P above the surface is 5.6 meter when the velocity is equal to 0 here. Right, I hope that is clear. It's pretty lengthy process there, but you can take shortcut in your algebra. Okay, just for clarification, I try to show every single steps here so that everyone is clear what is going on. All right, that is question 2. It took a while, but we managed to finish it. Now, do help me to check. In case there's any mistake, do drop a comment. Right? I'll be very happy to fix it. Right? Okay, next, number 3. Okay, let's see what do we have for number 3. I might just want to clean this up only. Hold on, I think I accidentally cleaned the other part there. Hold on. Okay, here we are. Number 3, find the speed of P immediately before it strikes the surface after descending. So find the speed immediately before it strikes the surface. So the number 3 is quite direct. Just before it strikes the surface, before landing. So before landing, we know that when it's about to land here, we know that the x must be 0 meter. Therefore, based on this equation here, our v square would be 312.5 e to the power 0 minus 250. And then we can see that this is 312.5 minus 250. That would actually give us, what do we have here? We have 6, we have 5, 7.5. 57.5. Therefore, the speed would be the square root of 57.5. Right, just let me try to get the GeoGebra to calculate this. Okay, so the speed of P immediately before you strike the surface is equal to 5.9, I think. Oh, sorry, 7.58. So 7.58 meter per second. All right, so I hope that is clear for first question. Okay, we're going to move on to the second questions now. Okay, second question. Here we have an object of mass 0.4 kg is projected vertically again, upward from the ground with an initial speed of 16 meter per second, and then it experienced a resistive force of magnitude 0.1 v x on the object during its ascent. where v represent the velocity at the time t after it starts to move. All right. So as usual, we have to represent or illustrate the mechanics first before we incorporate the mathematics in our analysis. Right? So initially, it was launched with a initial velocity of 16 meter per second. While it is in mid-air, now it has a weight, so don't forget this 0.4 g here. And then at the same time, it also experiences a resistive force of 0.1 v. Now, just like question number 1, by using Newton, so number 1, using Newton's second law, we know that the resultant force is directly proportional to its acceleration. The only resultant force here is negative 0.1 v and then negative 0.4 g, which will yield 0.4 dv dt here. Okay, again, to rearrange this neatly, I'm going to write in this form. That will be negative 0.1 v. Now, just to make a remark, we are using g equal to 10 Newton per kg. So therefore, we can write this as 4 instead. And then by simplifying, we have a rate of change in velocity is given as, let me see what we have here, negative 0.25 v minus 10 here. And then of course you can further factorize that. Hold on. So factorize that, v plus let me see, 40. Yep. So we have shown these differential equations to be true. Okay, so I hope that is clear for number 1. Okay, and then next for number 2, find the value of t at the instant that the object reaches its maximum height. So as usual, we need to solve this differential equation. So we have, before we try to solve it, let me just rewrite this format again. So we can rewrite as v plus 40 here, and then that is 0.25 dt. Okay. Now from here, we can reverse process the derivative by taking integration. Okay, this one is rather direct, so we can work with that quite easily. So we have ln v plus 40, always put a modular sign, and then equal to negative 0.25 time and c there. Okay, now based on the diagram, at t equal to 0, at t equal to 0 second, the velocity is equal to 16 meter per second. So we're going to substitute this into this equation. That would yield 16 plus 40 equal to, this is 0, so therefore c is equal to this. And then we can write down c as ln 56 here. And then after that, we can conclude the equations for velocity in this case by rewriting that. Plus ln 56. Okay. And then as usual, make it a habit to join the ln together. So if you join the ln, we have this 6 here, go to negative 0.25 t. Then we can say that v, I'm going to take a bit of a shortcut also here. that will be like, let me see, 56 e negative 0.25 t minus 40. Okay, so we need to find the time at the instant when the object reaches its maximum height. Okay, so I'm going to clean up this section first before we move on. Alright, at the maximum height. So at the maximum height, we know that velocity is equal to 0 meter per second. Okay. Now, therefore, 56 must be equal to 0. And then we have negative 0.25 t equal to 40, oops, sorry, 40 over 56 then. So that is 5 over 7. Therefore, we can get that quite easily from calculator. So just let me get my calculator here and let's see what do we have. We will have ln 5 over 7. Okay, and then divide by 0.25. So therefore it's 1.35. This is 1.35 seconds. So the time taken for the object to reach maximum height is 1.35 seconds. Okay, as usual, do check on your own. If there's any mistake, do drop me a comment. Okay, now that's it for question 2. We're going to move on to question 3. Okay, let's see, question 3. Okay, here we are, question 3. Let's read it up. So a particle P of mass 0.5 kg move on a horizontal surface along a straight line OA in the directions from O to A. The coefficient of frictions between P and the surface is 0.08. Air resistance of magnitude 0.2 V Newton oppose the motion, where V is the speed of P at time t. The particle passes through O with a speed 4 meters per second when t is equal to 0. Okay, as usual, make it a habit to illustrate the mechanics. Okay, just let me draw that. Particle P with a mass of 0.5 move in a horizontal on a horizontal surface along OA. Okay. Now along OA, so let's assume that it moves in this direction V. Okay, at t equal to 0 second, its velocity is equal to 4 meters per second. And then there is air resistance as it moves. There's an air resistance. Is there air resistance? Yep, correct. So there's an air resistance. Hold on, I shouldn't put it this way. It's very confusing. Okay, so hold on, just let me clean it up. I think in this case I would clean this up here. I'll just say that at t equal to 0 second, the initial velocity was 4 meters per second. And then there's an air resistance acting on the object. So this air resistance is given as 0.2 V. And then at the same time, there is a friction. So don't forget, there is a friction acting on the object also at the same time. So there's a friction here. Okay. This diagram was not drawn. Very well. Okay, hold on. Just let me clean everything up. Just let me redraw again. So initial draft. If you're not satisfied with that, do redraw again. I think if you spend more time on illustrating the mechanics, is more important than the math letter. Okay. So OA. So let's assume that here. At t equal to 0, initial velocity was 4 meter per second. It has a resistive force here. At the same time, it also experiences air resistance, also acting this opposite directions to the motion. Okay. And then what else? Just let me see. 0.4. Okay. And then F is frictional force is given by. Okay, hold on. Frictional force is given by. Let's assume it's limiting equilibrium. This is given by mu r, where the r is the normal reaction force. Given that the weight is 5 Newton here. All right. So I can further rewrite the friction as 0.08 R. We can see that based on Newton's second law, the R is basically 5 Newton, because those are the only vertical force acting on the object. So here I can write down as 5 here, which give me 0.4 Newton. Okay. Okay, basically those are the mechanics informations that I have illustrated. Now I'm going to start to analyze it in more detail by solving questions number 1 now. Show that we can have this differential equation that satisfies V with respect to time. Right. As usual, we're going to take Newton's second law. A resultant force in the horizontal direction is directly proportional to its acceleration. Okay, now in this case we have negative 0.2 V minus the frictional force, which is 0.4. That will give us 0.5. Acceleration is given as dv dt. Okay, as usual, I will write that down as 0.5 dv dt is equal to negative 0.2 V minus 0.4. Okay, so if I multiply by a 5 here, I get 2.5 dv dt. Okay, this one will be V. That one will be a 2. So if you factorize that, that will be V plus 2. Okay, so this has been shown. Alright, so number 1 is done. Oh yeah, before that, I've just done part 1 of number 1. And hence find the value of t when V is equal to 0. So as usual, in order to answer the next section here, we need to solve this differential equation. Right. So I'm going to, we are still on number 1 here. Okay, right. We have 2.5 dv dt is equal to negative V plus 2 here. As usual, grouping. So negative 1 over, let me see, should be 0.4 here, dt. Just let me check one more time if I got it correct. 10, yeah, negative 0.4. Therefore, we're going to reverse the process of differentiation. So here we have ln V plus 2, and then we have negative 0.4 t plus c. Okay. Right. Now, based on the information that is given at t equal to 0 second, t equal to 0 second, v is equal to 4 meter per second. 4 meter per second. Therefore, c is equal to ln 6. Okay. Now, before we can proceed further, we have to erase this first. Much place to write here. So we are still on number 1. Therefore, we can write this as ln v plus 2 equal to negative 0.4 t plus a ln 6 there. So from here we can write as ln 6 over v plus 2 is equal to 0.4 t, for instance. And then we have, let's see what we have here. So v plus 2, okay, v plus 2, that will be 6e negative 0.4 t. Therefore, v is equal to 6e negative 0.4 t minus 2 here. Now, there's the equations for velocity with respect to time. Now we need to find t when v is equal to 0. We have 6e negative 0.4 t minus 2 is equal to 0. Okay, so here we have e negative 0.4 t is equal to 1 over 3. Therefore, the time is, I'm going to solve it very quickly using the GeoGebra here. Okay, just let me move it a bit. So we have 3. Okay, and then we have 0.4 here. Okay, 2.75. So this is 2.75. Just let me write that, 2.75 seconds. And hence we have found the value of t when velocity is equal to 0. Okay, so I hope that is clear. Right. Okay. So I'm going to erase all this. Right, now second question. Show that dx dt is equal to this. Now we're going to make use of these equations that we have. So v is equal to 6e negative 0.4 t minus 2. We know that velocity is given as rate of change in displacement, which is this. And then there you have it. This has been shown. Okay, and hence we need to find the distance OP. We need to find the distance OP when v is equal to 0. Right. Now to do that, we need to solve this differential equation. Right. Now this one is rather more direct. We have 6e negative 0.4 t minus 2 dt. Right, so here we have, okay, let's see what we have here, 60, 15, so negative 15 e negative 0.4 t minus 2t here, plus c. Okay. So before we can get going, we're going to make use of our mechanics informations here. At time t equal to 0 second, displacement is equal to 0 meter. Okay, so we're going to substitute that. Therefore, c will be equal to, let's see, so c will be equal to, this is 0, 15, this is 0, so c is equal to 15. Therefore, we can conclude that displacement equation is given as negative 15 e negative 0 0.4t minus 2t plus 15 here. So we need to find the distant OP when v is equal to 0. Now when v is equal to 0, when v is equal to 0, we found that the time taken for v to be equal to 0 is 7.338, I think. Just let me refer again. Is it 7.38? 7.58, so sorry, it's divided by 1.3, oh sorry, it's 2.75. So the time taken when v is equal to 0 is 2.75. So we know that here, when v is equal to 0, t is equal to 2.75 seconds. Therefore, we're going to substitute this value into here. We have negative here, 0.4 by 2.75 minus 2.75 plus 15 here. Alright, so just let me quickly get my calculator and then tabulate this very quickly. So just let me key this one in here. So that is negative 15 e p there. We have a negative 0.4 by 2.75. Again, minus of that is what do we have? 5.5 plus 15. So what we have is 4.51. So this is 4.51 meters. That is the distant OP. Okay, I hope it is clear up to this question. Alright. Okay, I'm going to clean this up first. Okay. Question 4. Right, question 4. A particle P starts from a fixed point O and move in a straight line. When the displacement of P from O is x, its velocity is v, and its acceleration is given as such. Okay, as usual, illustrate the mechanics information. So we have particle P started from O, this particle P here, moving in this direction. Okay, and move in a straight line. Displacement is x here, and its velocity is v. Its acceleration is given as x plus 2 meter per second square. Okay, and then given that for first question, given that v is equal to 2 meter per second, when x is equal to 0 meter. Use integration to show that v square is can be satisfied by this equation. Right. So by using integration, the only expression that we can work with is acceleration. So we can begin to take that acceleration. We know that acceleration is given by v dv dx. Because we need to solve this acceleration equation in terms of x. Okay, so therefore this should be written as using this format instead. Okay, so from here we have v dv, and then we have 1 over x plus 2 dx. And then we have, after integration, we have ourselves plus c. Okay, we can continue from here. So when x is equal to 0, v is equal to 2. We're going to substitute this information here into this integrated equation. Therefore, in this case, we have ln 0 plus 2 plus c is equal to 2 square over 2, which is actually a 2. Therefore, we can say that ln c is actually 2 minus ln 2. Therefore, we can rewrite the equations for velocity, which is this. Plus 2 minus ln 2 here. Okay. So from here, we can rearrange, become x over 2 plus 1 plus a 2 here. Yeah, and then v square will be a 4 plus ln x over 2 plus 1. Oh yeah, there's a 2 there. And then let's just compare. Yes, so we managed to show this. All right. Okay, I hope that is clear. Okay, let's clean up a bit. Now we're going to move on to question 2. Find the value of v when acceleration of p is quarter. Right. So when acceleration is quarter, we know that 1 over x plus 2 is equal to a quarter. Now this implies that x must be equal to a 2 meters. Because x is equal to 2 meters, we can find v from here. So 2 meters. That will give us 4 plus ln, what do we have here? We have 2 ln 4 there. Therefore, velocity is equal to, just let me get my calculator here. We have square root of square root of 4 plus ln 4. Then that would yield 2.32. 2.32 meter per second. All right, there you go. Question 4. Let's clean up for next question. Question 5. Okay. A particle of mass 0.4 kilogram is released from rest at the top of a smooth plane inclined at 30 degrees, okay, to the horizontal. Okay. Now the motion of p down the slope is opposed by a force of magnitude 0.6x, where the x is the distance of p traveled down the slope. Okay, p come to rest before reaching the foot, of the slope. So therefore, we need to calculate the greatest speed of p during its motion. Okay, as usual, let's try to sketch out the mechanics information. Let's see, we have a slope here, something like this, and then it is inclined at 30 degrees. Okay, all right, now the object is somewhere at the top here, for instance. It's a smooth plane, so it has, just let me label that, it has a weight of 4 Newton. Okay, and then as it slides down, there is opposing force. There's an opposing force of 0.6 against the motion. So as it slides down, there's an opposing force of 0.6x there. And then it comes to rest just before you reach the foot here. Okay, so this is how it looks like. So before it reach B, for instance. Okay, so this is particle P here. All right, those are the informations that we have. Okay, let's put in more informations then before we get going. Yep, there's one more information I forgot to draw here. There is this normal force. Okay, there's a normal force here. This is 30 degree. Okay, that's what we have. All right, so now we are ready to apply Newton's second law. So first question, greatest speed of P during its motion. So let's start with Newton's second law. Resultant force is directly proportional to its acceleration. Okay. Now let's look at the directions where it moves. It's actually downward. Okay, downward. So the speed is downward here. Now the resultant force is given by W sine 30 subtract off with its resistive force, and then that would yield the acceleration. Yeah, before that, just let me put in 0.4. It's easier in this case. Acceleration, greatest speed during its motion. So I might want to just let me see, is there any other information that we have? Okay, not much informations, but I can write this as v dv dx. Okay, and then I'm going to substitute all the value that I have. So this is 4, sine 30 is a half, so this will become a 2. So therefore we have v dv dx equal to a 2 minus 0.6x. So from here we can rewrite this as v dx a 5, and then we have here 1.5x. Okay, as usual, we're going to group this, for instance. Okay, so maybe it's easier to work in this way. Just let me see. 1.5, 0.5 is a 3. Okay, so maybe it's easier to factorize this, for instance. We can factorize it as, let me see, so that we can work with the integration more easily. Okay, so just let me think for a while. Maybe it's good to take out 0.3 in this case. Sorry, it's not 0.3. It's 0.5. Take out 0.5 in this case. So there will be a 10, and then there will be a 3x. Maybe it's easier to work with this. And then here we have v dv, and then here this side we have 10 minus 3x here, dx integrations. So we have v squared over 2 is equal to 0.5 10x minus 1.5 x squared plus a c. Okay, plus a c. So at x equal to 0 meter, just let me see, it was released from rest, meaning that at t equal to 0 second, v should be 0 meter per second. That's what it meant here. So v is equal to 0 meter per second. Now we're going to substitute this into this equation. Now let me see, we have 0, this is 0, therefore it's quite obvious c is actually equal to 0. Then we can rewrite this equation as okay, so that will be 10x minus 1.5 x squared. Right. Now greatest speed of p during its motion. Greatest speed of p during its motion. Okay, during its motion. Right. Now, how should we do this? Maybe the best way is let's label this as a v. So therefore, we know that the speed is greatest when dv dx is equal to 0. So here we have 10, we have 3x. We're going to equate this to 0 to obtain the stationary value for speed. This implies that x is equal to 10 over 3. Okay. We know that this is the greatest speed because the second derivative is less than 0. Therefore, when x is equal to 10 over 3, its speed is maximum. So let's try to find its maximum speed. Okay. We're still on number 1. Okay. Speed, just let me write a few conclusions here. Speed is maximum when x is equal to 10 over 3 meters. So we're going to find the maximum speed. So maximum speed is given here. V is equal to 10 over 3 minus 1.5 3 squared. Therefore, V is, okay, let's try this. Yeah, let me try to use the calculator. Maybe it's faster, maybe it's slower, not sure. But let me give it a try. So we have 100 over 3. Subtract off with, this is 100 here, 15150. 150 over 9 there. So therefore is, let me see, what do we have? 16.67. So 16.7 meter per second. So the greatest speed of p during its motion is 16.7 meter per second when x is equal to 10 over 3. The distance, number 2, the distance traveled by p during its motion. The distance traveled by p during its motion. Okay, during its motion. We know that it comes to rest before it reaches the foot. Number 2, when it comes to rest, we know that v is equal to 0. So therefore, we can, v is equal to 0 or v squared equal to 0. Therefore, 10 is equal to 0 here. X can be equal to 0, or in this case, we have, let me see, is 123, so 20 over 3 second. Sorry, it's not second, it's meter. So the distance traveled by p during its motion, when it reached, just before it reached the foot, it has stopped moving. Now it will stop moving when x has reached 20 over 3. When x has reached 20 over 3. Therefore, distance traveled is equal to 20 over 3 meters. Alright, so I hope that is clear. Let's move on to 6 now. Okay, 6. A particle P of mass 0.5 kg move in a straight line on a smooth horizontal surface. The velocity p is v when displacement of p from O is x. So a single horizontal force of magnitude 0.16 exx on p in the direction of OP. Velocity of p when it is at 0 is 0.8. So let's try to illustrate the mechanics using a diagram. So in this case we have, sorry about my drawing, hold on. Okay, so we start from O. When t is equal to 0 second, the initial velocity is equal to 0.8 meter per second. Okay, and then the particle is moving in this direction. There is a force of 0.16 ex acting on the particle. Okay, the mass is 0.5, so that is mass mg is equal to 0.5 g. So that's the weight. Okay, at this point we are ready. As usual, show that v is equal to this. We are going to apply Newton's second law here. Okay, so using Newton's second law, resultant force is directly proportional to its acceleration as usual. Resultant force that we have here is only 0.16 ex, and then that would give me mv dv dx, which is the same as 0.5 v dv dx. So if I try to simplify this, I will get v dv dx equal to 0.8. This is 0.8. Did I get it wrong? This is 0.8. Yep, correct. Nothing wrong with that. So this is a 0.32. So 0.32 ex. Okay, that's the first differential equations that I have obtained. Now next I'm going to solve this. Okay, we can solve this. So it'll be v squared over 2. This one remain as it is, plus a c. And then we know that we don't know that at x equal to 0 meter, v is equal to 0.8 meter per second. Therefore, we're going to make use of this information here to obtain the full equations for velocity. V squared, v squared is 0.8 square here, divided by 2, 0.32, 0.32 e to the power 0 plus a c. Therefore, c is equal to 0.32, that's 0.32, okay, 64 to 0.32, yep, 0.32 minus 0.32, which yields 0. Therefore, we can write the equations for the velocity as 0.32 ex, yeah, and then v squared is equal to 0.64 ex. Okay. Now, if we compare this equation and this, it may not be the same because this one does not have a square. Therefore, I'm going to square root this, which will yield 0.8 ex over 2. And then this has been shown. Okay, so I hope that is clear. Now next, find the time taken by P to travel 1.4 meter. 1.4 meter. Time taken by P to travel 1.4 meter from O. Okay. From O. Let's try. 2. Time taken. So we're going to use v equal to 0.8 ex over 2 here. Velocity is rate of change in displacement, which is the same as this. Okay, and then we're going to solve this differential equation. Okay, so we have dx e negative x over 2 equal to 0.8 dt. So we're going to integrate this. And then here we will have negative 2e negative x over 2 equal to 0.8 t plus c. Okay, and then at t equal to 0, x is equal to 0. So therefore, this implies that c is, this is 0, this is 0, implies c is equal to negative 2. Yep, so therefore these equations become ex over 2 equal to 0.8 t minus 2. So we need to find the time taken by p to travel 1.4 meter from O. Okay, so now I'm going to erase off this so that we can move with this. So at x equal to 1.4 meters, so we have 0.8 t minus 2 is equal to negative 2e negative 1.4 divided by 2, which is the same as negative 2e negative 0.7. And then we're going to finish this algebra here. That will be 2 minus 2e negative 0.7. Therefore, we can find the time here. Right. Just let me get my algebra. Okay, let's see what we have. Okay, that is 2 minus 2 exponential negative 0.7. Okay, that's what we have. And then we have to divide by 0.8. So 1.26. Okay, just let me write down 1.26 seconds. So the time taken by P to travel 1.4 meters is 1.26 seconds. I hope that's clear. Okay, so I'm going to clean this up. I'm going to go to next question, 7. Okay. A particle P of mass 0.3 kg is projected vertically upward again from the ground with the initial velocity of 20 meters per second. Now you get used to how the questions been phrased. Okay. So when P is at a height x meter above the ground, its upward speed is v. It is given that velocity and displacement satisfy these equations here, where a is a constant. Right. Now the question is differentiate this equation with respect to x, and hence shows that acceleration of the particle is this. Okay, so nevertheless, even though it's quite direct here, is as I said, it's always good to illustrate the mechanics for this. Yeah, this is the ground. It's been projected upward with the initial velocity of when time t is equal to 0, initial velocity is 20 meter per second. So at time t equal to 0 second. Okay, and then any other forces acting on the object? No. So the only force that is acting on the object at this point is the weight, which is 3 Newton in this case. Okay. V is the upward velocity. Okay, so I think we are ready at this point. So when t is equal to 0, u is this, x is equal to 0 meter. Alright, now we are ready. Okay, number 1. Using this, it is given that this is this. So I'm going to copy that down. Ln v plus 30 plus x is equal to a. Now I'm going to differentiate this this way. So I'm going to, hold on, just let me change that so that's something more visible. Differentiate this with respect to displacement. Okay, so therefore this is 3v90 ln. Okay, and then do the same for the other side. Differentiate that with respect to x. Okay, where a is a constant. Because a is a constant, therefore this result will yield a 0. And then next we're going to differentiate this now. So the differentiation for this will be 3dv dx. And then this one here would be, alright, now this one is tougher. Okay, this one is actually negative 90. Alright, now that would be 1 over v plus 30 dv dx. And then the last one is quite direct, which is 1 equal to a 0 there. Okay, so I hope that is clear at this point. Okay, some of you might be wondering how do I actually differentiate this to become these sections here. So therefore I'm going to highlight this part here. I'm going to show it this section here so that everyone is clear how this result has been reached. Okay. So for this we have differentiation of 90 ln v plus 30 this case. Okay, so that is what we have. So first of all, we can let let's take for instance, let y equal to v plus 30. Let y equal to v plus 30. Sorry, not y plus 30. Sorry, it's supposed to be let y equal to ln v plus 30. Yeah. And then here we can apply a bit of chain rule. dy dv. dy dv is basically 1 over v plus 30. Okay. Alright. And then this is basically, this is to do this, to get our dy dx, which is this section here. Okay, to get the dy dx, hold on, I think here is clearer if I put 90 here. So there's a 90 here, so it's easier to relate. So there's 90. And then if I want to carry out this dy dx, now dy dx is the same as dy dv crossed by dv dx. And then I have obtained my dy dv, which is 90 over v plus 30 crossed by my dv dx. Okay, so that's how this result is being produced. I hope that is clear. Okay, so I'll give you a few minutes to organize your thoughts on that. Alright, okay, just let me clean this up. We're going to continue from this section onward. Okay, so from here we will have we need to get its acceleration. We know that acceleration is given as v dv dx. Okay, so in order to do that, we might need to restructure a bit here. Okay, so we want to multiply v throughout this equation here. So we have 3v dv dx minus minus 90 over v plus 30 v dv dx equal to minus v. Then I'm going to bring this over to the other side. So from here we have 3 v dv dx is 3 acceleration minus 90 over v plus 30 acceleration also equal to negative v. So therefore I can join these two together. So I can join these two together. That will be 3v plus 90 minus 90 here over v plus 30 a equal to negative v. So from here we notice that a acceleration is actually equal to now let me see what we have here. We have a v has been cancelled, so negative 1 over 3 v plus 30 meter per second square. So that has been shown. Right, so I hope that is clear for question 1. Okay, second question. Find in terms of V the resisting force acting on the particle. Resisting force acting on the particle itself. Alright, so just let me see what resisting force. We have shown that the acceleration is equal to that. Okay. So now we need to find in terms of V the resisting force. Okay, resisting force. Okay, let's give it a try. Second question. Now, as the object fall due to its weight, there is a resistive force based on this. So therefore, we're going to label the resistive force as F. Okay, resistive force. Right? Now, based on Newton's second law, resultant force is directly proportional to its acceleration, as usual. Okay, and then the resultant force in this case is given by F minus the weight, and then this will produce the acceleration. Okay, its acceleration is negative, that's fine. So in this case we have acceleration. So resistive force is given by this resistive force. So resistive force F is equal to 3 minus 0.1 V minus a 3 here, minus a 3. Let me see. Yes, correct. Therefore, resistive force is negative 0.1 V Newton. Right. So I hope that is clear in this case. Okay. Right, now lastly, we need to find the time taken for P. Time taken for P to reach its maximum height. Time taken for P to reach its maximum height. Okay. Right, now let's see what we have here. Okay, let's see the rest of this. So we have acceleration. We're going to work with number 3 now. Acceleration is equal to this. Okay, acceleration. And then acceleration is dv dt. Okay, that is rate of change in velocity. We're going to solve this differential equation before we can proceed on answering this question here. Okay, as usual, we're going to group them. Okay, that will give us v plus 30 plus a c there. Okay, just let me clean up the rest. Okay, at this point we know that at t equals 0, u is equal to 20, x is equal to 0 then. So at t equal to 0 second, v is equal to 20 meter per second. Okay, let's use these informations to work out the c. Okay, let's see what do we have. Therefore c in this case basically is equal to 50. Then we can rewrite this as v plus 30 equal to negative 3t plus ln 50. Okay, that will be v plus 30 over 50 equal to negative 1 over 3t. Therefore, v is equal to 50 e minus 30 meter per second. Okay, so the time taken for p to reach its maximum height. At maximum height, we know that v must be equal to 0 meter per second. Therefore, in this case, 50e negative 1 over 3t minus 30 must be equal to 0. Now I'm going to simplify the work here just to find out the time that we need. Okay, hold on, just let me get my calculator here. So that will be a ln 3 over 5. Okay, and then m just multiplied by 3 here. Okay, so it's 1.553. 1.53 second. So it takes about 1.53 second for p to reach its maximum height. Alright, so I hope that you guys are clear on this question. Okay. Alright, let's move on. Question 8. A particle P of mass 0.25 move in a straight line on a smooth horizontal surface. P start at point O with speed 10 meter per second and move towards a fixed point A on the line. Okay. At time t, the displacement of P from O is x and the velocity of P is v. Resistive force of magnitude 5 minus x Newton x on P in the direction towards O. Okay, cool. So let's try to illustrate the mechanics on this. So we have O here, we have A. The particle is moving towards a fixed point A. Its velocity is v. At time t equal to 0 second, its initial velocity was 10 meter per second. And then there's a resistive force acting on the particle in the opposite direction, which is given as here, F. So the F is given as 5 minus x Newton. Okay. Let me see any other information given. It has a mass of 0.25 g. Okay. Okay, basically that's all we have. All right, now let's work out the number 1. Form a differential equations in term of in v and x. Then by solving this differential equation, we need to show that v satisfies this equation. Okay. Now, as usual, we will start from Newton's second law. It's Newton's second law. Okay. The resultant force that we have is only negative phi minus x, which is the same as 0.25 v dv dx. Okay, and then by arranging this, we have v dv dx is actually equal to negative 4 phi minus x. Okay, we're going to solve this differential equation. So we have 4 phi minus x dx here. So we have v squared over 2 negative 4 phi x negative x squared over 2 plus a c. Okay, we can proceed from here. We know that at t equals 0, velocity is equal to 10, and then the initial displacement was equal to 0 meter. Okay, so for this information, we can write down 10 squared over 2. X are all 0, therefore c is equal to this. C implies that the c is equal to 50. Therefore, you can rewrite the equations for velocity. We have here, just let me take out the 4 phi x minus x squared over 2 plus 50. Right. And then we can simplify this, I think. Just let me see, did I get this correctly or not? What done? Phi x v. Yep, correct. That is absolutely correct. So I'm going to multiply that by 8. So that would be 4 10x minus x squared plus 100, and then that will be equal to, let me see, 4x squared minus 4dx plus 100. Okay, and then this v squared is equal to, just let me try this out to see whether we can factorize this easily. So let me see, you have x squared minus 10 x plus 25 here, so x minus 5 squared 4. Alright, so therefore this is actually 4x minus 5 squared. Therefore v is equal to 2 x minus 5. Given that v is in the positive directions, now bear in mind whenever you square root there is always a plus or minus, but here we tend to choose v is equal to 2x minus 5 because the directions to the right is considered as positive in our analysis here. Therefore, we have verified these equations here, which is, did I get that right? Hold on now. I don't think I get that right though. V is equal to plus, okay. Hold on, the velocity V is V, yes, correct. In this case, we are supposed to have negative velocity. Form an equation by solving this. Okay, so let me see if I did anything wrong here. X minus 5 is a positive 2x minus 5. That is interesting. So just let me check one more time in case I got anything wrong here. 4 is a 1. There's a 4 there. Okay, so therefore when x is equal to 0, v is equal to 150, so c is equal to 50. Why the v is negative in this case? Just let me read that one more time in case I make a mistake here. Hold on, and move towards a fixed point at time t. The displacement of p from O is x. Velocity is a v. Velocity is a v here. Okay. Velocity is v. Resistive force x on p in the direction towards O. So v is moving that direction. Okay. Resistive force of negative. So that is negative. Definitely correct. Straight line of move. Speed of 10. Speed of 10. Phi x plus v here. Alright, just let me pause this section here, stumbling block. Okay. Yeah, is a good stumbling block for us to think about at this point. As I said, whenever we have a square, when you take square root, there must be a plus or minus. Yep. But to delve into more detail in terms of mechanics here, we are going to look at the mechanics based on this diagram here to decide whether we're going to take v equal to plus or v equal to minus here. Right, now let me erase this section here. Okay. So let's start from assuming that we have v equal to plus, for instance. So that is 2x minus 5. So case 1 here. We're going to try to verify whether case 1 fit in our description. Okay. At x equal to 0 meter, which means at the beginning of the motion, we found that b is equal to negative 10 meter per second. So since v equal to negative 10 meter per second, the object should be moving in this direction if the v is negative. So it shouldn't be moving in the directions towards A. Okay. Now never mind, we're going to verify case 2 then. Case 2 is when v is negative here. Okay. And then that is what we have as 10 minus 2x here. At x equal to 0 meter, v is equal to 10 meter per second. Yes, that fit in this description exactly in that direction towards A. Therefore, we will choose v equal to 10 minus 2x. And then this has been proven. Right. So sometimes I also miss out this section here. It is a good point to analyze the mechanics more rather than depend on the math itself. Okay, so I hope that is clear. Alright, now second section here. We have find x in terms of t and hence show that particle is always less than 5 meters from O. Okay. So because our v is equal to 10 minus 2x, velocity is rate of change in displacement. And then we're going to solve this differential equation. We have what we have here. Let's see what we have. We have dx 10 minus 2x equal to dt here. So we're going to integrate this. Okay. All right, integrate this. Up to you how you want to do that. Just let me show you how we're going to do it correctly. Okay. I'm going to proceed on here. We will let y be 10 minus 2x. dy dx is equal to negative 2 here. Therefore, we can write down dx is actually negative half dy. Okay. So therefore, this section here will become what will it become? It will become negative half dy, and this become dy over y here equal to the right hand side expressions will be much more easier to integrate. That is basically just t plus c. And then from here we have negative half ln y. Yes, but what is y? Y is 10 minus 2x equal to t plus c. Okay, as usual, from here, we are going to obtain the c. So at t equals 0, x is equal to 0 meters also. Therefore, we're going to substitute all this inside here. T equals 0, that is equal to 0. Therefore, c is equal to negative half ln 10. Then we can write our expression for displacement, which is here. We have negative half ln 10 minus 2x is equal to t minus half ln 10. Okay. And then as usual, we're going to combine these two together. We have half ln 10 divided by 10 minus 2x equal to t, and then that will be 2t, 2t, and then that will be 10 minus 2x equal to 10 over negative 2t, and then therefore x is equal to 5, let me see, 10, 5 minus 5 minus 10 minus 10, half 10 negative 2t. Did I get that correctly? No, I think I missed out one. Okay, hold on, just let me fix that. Alright. So from here, if we simplify it correctly, we should have, what are we supposed to have here? We're supposed to have 10 minus 2x equal to 10e negative 2t. And then therefore we have x equal to 5 minus 5e negative 2t. Right, now that will be our expression for x in terms of t. Okay, so I hope that is clear. And then lastly, they want us to show that the particle is always less than 5 meters from O. Always less than 5 meters from O. Okay, now that is, I'm going to erase all this. Okay, we're going to work on this one here. Right, now based on this equation here, equation for displacement, we have 5 minus 5e negative 2t here. Now, because e negative 2t is always greater than 0, Therefore, 5e negative 2t must be greater than 0 also. It must be greater than 0 also. And then negative 5e negative 2t must be less than 0. 5 minus 5e negative 2t must be less than 5. And then hence, we say that the displacement is always less than 5 meters. So I hope that will be clear for all of you. Okay. Now we're going to go to the last question. All right. Question of the day. All right, last one. Okay, here we have a cyclist and her bicycle have a total mass of 60 kg. Right, cyclist rides in a horizontal straight line and exert a constant force in the directions of motion of 150 Newton. The motion is opposed by a resistance of magnitude 12V, where V is a meter per second. It's a cyclist's speed at the time t passing through a fixed point. Okay, just let us illustrate that. So it starts from passing through a fixed point A. So let's assume that this is fixed point A. Okay, at t equals 0, so at t equals 0, the x should be equal to 0 meter. Alright, and then the cyclist and the bicycle experience a forward force of 150 Newton, and then at the same time there is a resistance of 12V acting in the opposite direction. The mass is 60 kg. Right, so now we are good to go. Now based on this diagram here, and then based on Newton's second law again, we are interested in the horizontal direction. Okay, so the resultant force will be 150 minus of 12V, and then that would produce 60 dV dt. Okay, so from here we divide by 12, so dV dt, you try to divide all the equations by 12. Okay, so that is 12. Okay, so we have V here, minus V if we divide by 12. So 12, 30, 12, 2, 24. Okay, that will be a 5, and then 150 divided by 12 minus a V here. Okay, let me see. 3, 4, 350. Okay, 4, 1, 4, 2, 8, 12.5. So this becomes 12.5 minus V. And then we have managed to show this. Okay. Right. Now number 2. Given that the cyclist passes through A with a speed of passes through A with a speed of 1.5 meter per second in this case. Solve this differential equation and then show that V satisfies this equation. Okay, so let's try to work out here. This is number 2. Okay, let me work out here, number 2. Okay, we're going to solve this. That will be a 5 over 12.5 minus V dV, and then that will be a dt. Okay, so that's what we are having. Okay. Now as usual, by using a bit of substitutions, we can show that this is actually negative 5 ln 12.5 minus v equal to t plus c. Okay. At t equal to 0 second, we know that v is equal to 11.5 meter per second. So we're going to substitute this information into this equation. All right, now let's see what we have. We have c equal to negative 5 ln 11.5, which is actually a 1. That is actually a 0. Therefore, we can rewrite this. Okay, I'm going to write this one down here. It's easier to see. Now we can rewrite this as negative ln 12.5 minus a v is equal to t plus a 0 here. Okay, and then we can rewrite this as 12.5 minus v is equal to e negative 0.2t. Therefore, v is 12.5 minus e negative 0.2t here. And then, yes. Okay, we'll see solve this equation. Okay, so we managed to show this. Right, so I hope that is clear. And then lastly, we need to express the displacement of the cyclist from A in terms of t. That is, as usual, we're going to write v in terms of dx dt. Okay, just solve this differential equation. Now that would actually give us x equal to 12.5. I'm going to integrate that directly here. In this case, I will have a plus 5e negative 0.2t plus c. We know that at t equals 0, x is equal to 0. So t equals 0, x is equal to 0. This is 0, therefore c is equal to negative 5. That will bring us x equal to 12.5t plus 5 exponential negative 0.2t minus a 5. And then that is the expression for our displacement. Alright, that is all for today. I hope this has been a helpful tutorial for all my students. If you are interested with this video, do subscribe so that in the future you get updates on any videos that I will be uploading. Alright, thank you very much.